Hello to JCB viewers. Welcome to JCB EduBuild Solutions, founded by engineer James Bolo. Today our discussion will be plumbing arithmetic. We are grounding today's derivations directly in the Master Plumbing Reference 2 2nd edition. Looking at the syllabus overview provided in the text, we face a 100-item examination, strictly timed at 2 hours, spanning 5 major areas in math and physics. We will dissect the 3 highest yield subjects required for the exam: applied physics, financial arithmetic, and miscellaneous pattern recognition. The board exam tests your ability to apply theory under severe time constraints. Speed, computational accuracy, and perfect unit consistency are the only ways to secure a passing grade. Fluid mechanics forms the absolute foundation of any plumbing system design. Our primary metric here is discharge, represented by the variable Q. Discharge is the direct product of 2 variables, the cross-sectional area of the pipe, A, and the velocity of the fluid, V. Because the pipe is cylindrical, that cross-sectional area is a geometric function of its diameter. This means the constant pi is permanently baked into every discharge calculation. Kapag nagbago ang pipe size, ano ang mangyayari sa flow? To maintain the exact same volume of discharge when forcing fluid through a narrower pipe, the fluid velocity must increase. They share a strict inverse relationship. When water is at rest, we calculate fluid pressure, or P, by multiplying the unit weight of water by its vertical head, or height. This reference table provides the exact conversion factor we need to make that calculation. 1 foot of water column generates exactly 0.433 pounds per square inch of pressure. Looking at example 1, which asks for the pressure at the base of a 30-foot water cylinder, the arithmetic is straightforward. 30 feet times 0.433 yields 12.99 psi. The trap here is unit verification. Examinees routinely fail because they blindly apply that 0.433 multiplier without checking if the given elevation is in feet or inches first. Passing the physics portion of the exam relies entirely on identifying these invisible conversion factors that bridge physical height to actual pressure. A master plumber's responsibilities extend beyond physical pipes into project bidding and equipment depreciation. This requires a firm grasp of engineering economy. Kapag may interest on cost, paano natin kukunin ang future value? This page outlines the simple interest formula. Interest equals principal times the interest rate times the number of periods. For ordinary simple interest, we strictly use a standard banker's year, defined as 360 days. Consider a loan scenario where a plumber borrows 20,000 pesos at a 6% interest rate for exactly 120 days. Because we use a banker's year, our time variable n cannot be just 120. It must be entered as the fraction 120 over 360. This behaves very differently from compound interest. Here, accumulated interest is added back to the principal, causing the total to grow exponentially over time. In the compound interest formula, the time variable n is the product of the number of years t and the compounding periods per year m, such as 12 for monthly or 4 for quarterly. The most common error across all financial arithmetic is a failure of alignment. If you do not perfectly match your time period n with your compounding interest period before touching the calculator, the final output will be incorrect. Miscellaneous word problems are intentionally designed to bury these exact formulas beneath paragraphs of narrative text. Ano ang unang step kapag ganito ang problem? You must immediately isolate the given variables from the required output. Question 84 from the reviewer demonstrates this perfectly. We have a machine with a first cost of 7,350 pesos, an 8-year useful life, and a 350 peso salvage value. Before doing any math, isolate the requirement. We need the specific book value at the exact end of year 4. This page details the straight line method formula for the annual depreciation charge. First cost minus salvage value, divided by the useful life. Inputting our givens, 7,350 minus 350 leaves 7,000. Divide that by 8 years and we get an annual depreciation of 875 pesos. Since the problem asks for the state of the asset at year 4, we multiply that 875 by 4. Yielding an accumulated depreciation of 3,500 pesos. We then subtract that accumulated 3,500 from our original 7,350 peso first cost. This provides our final book value of 3,850 pesos. The trap is set in the multiple choices. Examinees will calculate the 3,500 total depreciation, see it as an option, and select it, completely forgetting that the prompt required the remaining book value. Let's consolidate the core mathematical framework we derived today. Discharge requires area and velocity. Pressure requires vertical height and a conversion factor. Compound future value relies on exponential periods, and straight-line depreciation requires isolating the annual charge first. Kung may lalabas sa exam, malaking chance nandito sa tatlong ito. If gusto nyo ng mas maraming ganitong problems, message nyo lang kami. Meron kaming complete reviewers, videos, and practice exams ready. Thank you JCB viewers for listening, and for those who are not yet following, please follow us for more contents and free reviewers for you. See you on the next topic. Audio fades out.